Question number 1 and question number 2 are piece of cake. I will go through question number 3. We need to draw a layout to cover this area of land. You have this property and you need to build warehouse or you need to cover this area using truss or trusses. Make sure, be careful, without any intermediate columns inside this area, without any intermediate column. So I believe I will make my main system in this direction. We should have a column here and another column there, and the truss will be in between. So the total span of this truss will be 130. Will cover this main system, will cover this area of land until this boundary. So we have column at these edges. Do you agree? The span of this truss will be 130. So I believe I can draw this truss like this. Probably fixed or hinged, whatever the supports. This total span will be 130 feet. It's up to you. You can do what you want for this truss. Probably you can divide it to 6.5 for time interval. You can draw your diagonals like this and the opposite diagonal like this. So the trusses used to cover this area of land, the span will be 130. They need to cover this length of 150. So I'm gonna assume this distance between each main system, probably 15 feet, probably 30 feet. It's up to you. Do you remember I gave you ranges last meeting? So you can assume the spacing, but make sure you are selecting equal spacing. This spacing will be equal. Then I will use another truss spanning from this side to this side, like this. Another truss with 2 columns on the 2 edges of the land of the area, like this. This truss will span 75 feet. I will assume my truss looks like this. That's fine. That's fine. Or I will assume this truss to be like this. Because from this point to this point represent this part. So the remaining truss, I can do it on the same level with the same slope. So this one will parallel to this one. And then you can divide it to interval and diagonals, like this. And fix it. Whatever the shape of the truss, I don't care. It's up to you. But to cover this area, your plan must be looks like this. We should have two trusses because we have two different shape of area. Good morning, Ihab. So do you have any comment about this point? Is it clear for you? Okay, looks good. Looks good. Okay, I would like to give you a hint because this hint is very important. If you go to Walmart and watch the roof for Walmart, you can find the trusses. And this truss is supported here by column and supported here by another column. And this truss is divided to intervals. My question is, do you think which one is better to put your diagonal like this or like this? We need at least one diagonal. At least one diagonal is enough. But my question is, which direction of this diagonal, like this or like this? Any answer? You need to understand what is the meaning. How can I lay out the diagonals of trusses so I can choose the perfect shape of the main system? The first one, top right to bottom left. Top right, bottom left. Okay. So do you have a rule? Yeah, I know probably you saw many trusses before, so you can say like you did. But do you have a rule for this? What is the rules? Or what are the rules to choose the diagonals? Because sometimes your truss looks like cantilever. It's supported from this side only. And this side is free. Probably you have bridge or you have parking area. It's supported from one side. If you divide this truss to to interval like this, what is the best direction of diagonals? Do you think this direction is better or this direction? What do you think? So we need to understand what is the rule behind the location of diagonals. Okay? That makes sense? Because this one is different than the first one. So we need to understand the rule. Okay. Guys, the first truss is supported by this support and this support. Do you agree? So this truss looks like a beam and you have load on this truss. Can you imagine what is the deformation of this truss? The deformation looks like this. That's right. This is the deformation, the expected deformation of the truss. I believe all of you agree with this. Your diagonals will be tangent to this deformed shape. Tangent. What you mean by tangent? I mean this curve, if you would like to draw a tangent, it will be like this. Your diagonal will be like this. This curve, if you would like to draw a tangent, will be like this. Your diagonal will be like this. On the other side, if you would like to draw a tangent to this curve, your diagonal will be like this. Tangent, your diagonal will be like this. At the midpoint, probably the best scenario will be like this and like this. Because at this location, your tangent will be horizontal. So I can draw this one okay, this one is okay, both of them okay. Do you agree? Do you have any question for this rule? For the second truss, imagine this truss looks like a beam fixed from one side and free from the other side. Looks like a cantilever. And you have applied load on this cantilever. What is your expectation about deformed shape? What do you think? I believe your deformation will be like this. You agree? Your diagonal will be tangent to this curve. If you would like to draw tangent, 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 I believe your diagonals will be like this. This is the best orientation for diagonals. So if you have a truss and you would like to decide how can I lay out the diagonals, please imagine what is the deformed shape. We have only two cases, nothing more. If the truss is supported between two columns like this, so your diagonal must be tangent to this deformed shape. If your truss is supported from one side and free from the other side, your deformed shape looks like a cantilever. So your diagonals will be, all of them will be in the same direction. Guys, do you have any question for this point? Do you have any question for the homework? I hope to see some AutoCAD files for homework number 1. I hope. Or at least a clear sketch. So guys, do you have any question? Any comment? Okay, guy, Brian, do you remember no means two things. No means we don't have question, we are good, we are understanding everything, or we don't care. Okay, thank you. Okay, guys. So let's do another challenge for today. Before going through our topic today, I would like to give you some hint. Few hints. Let's do another drawing, which is good. This truss with interval like this and the diagonals. This spacing will be equal, most of the time are equal, with distance A. And this inclined spacing will be called A prime. And one more thing, if you have area of land like this, and you decided to put your main system in this direction, so we have column here, another column, this column, and this column, and the truss is this line, and this main system is repeated at equal spacing, this spacing can be called S. So S is the spacing between main system. A is the horizontal spacing for truss. A prime is the inclined spacing. So if you open your homework one more time, sorry for that, I can figure out the distance here, which is S. I can figure out the distance A. I can figure out the distance A prime. Please be familiar with these spacing, S, A, and A prime. Okay. We need to do loading and analysis of trusses. Our meeting today will be about loading and analysis of trusses. We will cover in this course 4 loads or 2 types of load. Primary load, which are dead load and live load. And we have secondary load, not all the time are existing. Wind load and snow load. So I will cover today dead load, how much, live load, how much, and I will go through the wind load. Next time I will cover snow load and how can we do truss analysis using RISA. Do you remember? RISA 2D. Okay, and also we learned before, if you have these kinds of load, we have something called combination, so we can add them together to figure out the maximum or the worst case. So we have 7 combination. I will use the maximum 1, okay, or the critical 1. Let's start with the first type of load, dead load. Dead load. We have 2 types of dead load. Just to remind you what we learned last meeting. So guys, for dead load, we have weight for main system, on weight for the main system. In this case, our frame, or this case, our truss. We have something called Berlin. Do you remember that? These Berlins are in the longitudinal direction like this for frame, or like this at each joint for trusses. We have bracing, horizontal bracing, this cross, this cross, this cross for wind load. And we have side girths on this side and the other side and this side. The weight for all of these components, main system, truss, Berlins, bracing, horizontal bracing, and the side girths, I can assume the weight for truss member, Berlin, connection, wind bracing, all of these members around 100 to 200 pound per square feet. And this type of load, which is weight of the steel structure, is horizontal projection. Keep it in your mind. Horizontal projection. To cover the purlin, we have something called corrugated sheet. Sometimes this corrugated sheet is filled with concrete. Sometimes we don't have concrete, we have only corrugated sheet. So your roof or your covering material, sometimes it's a flexible roof, just only corrugated steel sheet. At this case, we can assume the weight for this corrugated sheet something between 25 to 50 pound per square feet. I'm giving you a range, so you can choose something in between. And this weight can be considered inclined projection. Sometimes this corrugated sheet is filled with concrete. So we can consider this roof as rigid roof, filled with concrete slab. At this time, the weight of the concrete slab equal gamma thickness. Gamma of concrete, do you remember last semester? Gamma of concrete equal 150, and the T is the thickness of the slab. And this weight can be considered inclined projection. So Burak probably, or Alex, or anybody, Brian, or anybody can ask me a good question. 100 to 200 is, there is a big range. So do you think I will assume it 100 or 200 or 150? What do you think? Do you have any suggestion or any comment about this range? How can I assume the range for the weight? Because I didn't design yet. I'm assuming the weight of the structure. So how can I do it? Thank you, Oliver. Good answer. Thank you so much. Yes. Guys, do you remember I told you before the spacing range between main system, something between 15 to 30 feet. If you decide to use the minimum spacing 15, that means we have many main system. We have many trusses. We have a lot of weight. So I'm gonna assume the weight is 200. Or if you assume the spacing is 30 feet, so we have long or long distance, long spacing. We have minimum or we have little of main system. So we have less weight. So I'm gonna assume it 100. If you decide to use probably 20 or 25, something in between this range, I'm gonna assume my weight something in between 150, for example, pound per square feet. So please make sure you are selecting a range of spacing, and it depends based on this range. I'm gonna assume the range used for weight of the structure. So for dead load, we have two weight of structure, of steel structure itself, main system, purlins, connections, wind bracing, all of this stuff can be called W structure. Covering for the roof will be called WC. And this covering probably can be flexible or rigid based on, do you have concrete filled the corrugated sheet or just corrugated sheet? It depends. The other difference for W structure, this one is horizontal projection, but this one is inclined projection. What is the difference? What is the meaning of horizontal and inclined projection? I will cover it soon. Guys, before going through the next step, if you have surface load, W, surface means on area. If I would like to convert the surface load to one concentrated load, what should I do? If you have surface load on area and you need to convert this surface load to one concentrated load, what should I do? Oliver, one more time. So everybody left and Oliver is still here only? Or you guys are still here? So you need to multiply it by area. This area, if you multiply this area by W, I can get concentrated load P. Does that make sense? That makes sense. Okay. If you have a truss as a main system here, like this, and this truss is repeated one more time, like this. And we need, and we have Berlin. Oh, okay, wait for the Berlin. And we have another truss here. And we need to convert the dead load to concentrated load at each joint of the truss. Okay. Can you tell me what is the area assigned to this joint? If you divide the distance between this truss and this truss, and this truss and this truss, if you divide the distance between this joint and this joint, this joint and this joint, I believe this is the area assigned to this joint. Can you tell me what is the dimension of this area? Yeah, I can tell you. This distance will be spacing S. This distance will be distance A. Because the distance A is the distance between each joint. And the distance S is the distance between each main system. So, I believe if you have dead load equal W, and you have area assigned to each joint of the truss, and this area is spacing time A, if you multiply this weight by this area, you can convert this dead load to concentrated load at each joint of the truss. Guys, in structure analysis, if you remember, all trusses you learned in structure analysis, you found the load are concentrated load at each joint. How can I convert dead load or live load or any load which are surface load on area? How can I convert this area load to concentrated load? It's very simple. This joint is serving between this line and this line, and serving between this line and this line between the main system and the other main system. So this area is assigned to this joint. What is the dimension of this area? Is A times S. If you multiply this area by the value of the weight, you can get a concentrated load representing your dead load. Any question? So we have layout. This is plan. We have S, spacing between main system. We have A, spacing between joints or spacing between purlins. Because the spacing between this joint and this joint, the horizontal spacing A will be also the same distance between purlins, because your purlins will be at the location of the joint. Anyway, so the first one, W structure, will be multiplied by A times S. This is the area assigned to each joint. A is the horizontal distance. For WC covering the second value of the dead load, which is covering, will be multiplied by S times A bar. This is area also, but this one is horizontal area and this one is inclined area. I'm sorry, what you mean by inclined? I will let you know. Inclined area means between this center line and this center line, this area. Inclined area. Horizontal area means between this center and center line, this is a horizontal area. Not inclined area. Why you are using horizontal area for W structure and inclined area for covering weight? Because weight of structure is in horizontal projection. So you need horizontal area. For weight of covering flexible roof or rigid roof, we need inclined area. Why? Because this load is inclined projection. Once you convert your dead load, which is surface load, to concentrated load, please add them together. PS plus PC, BS plus BC. I can figure out, or I can get the final dead load as a concentrated load at each joint. Half of this value will be at the end, at this joint, and half at this joint. Do you know why half? Because this joint is supporting only one side. We don't have another side. This one is supporting from this side only. We don't have something on the other side. So the concentrated load here will be half value of this concentrated load. It's very simple. For example, I will assume W structure something about 150 pounds per square feet. Something between this range. And W covering, it's a corrugated sheet without concrete. So I'm going to assume something in between around 30 pounds per square feet. For some reason, I draw my layout and I choose the spacing equal 20 feet. And my selected truss give me distance A equal 6 feet and the inclined distance equal A prime equal 6.5 feet. That's fine. So we have PS, we have B covering, B structure, B cover. B structure will be 150 times horizontal area, which is 6 feet times spacing 20. And your covering load will be 30 times inclined area. So I'm gonna use A prime 6.5 times spacing 20. And then the final B dead load will be PS plus PC equal. Just a moment, I will get my calculator. Mm-hmm. 150 times 6 times 20 equal 18,000 pound or 18 keb. 30 times 6.5 times 20 equal 3,900 pound or 3.9 keb. That means your final dead load will be 21.9 keb. So finally, your truss will have concentrated load at each joint. How much? 21.9, 21.9, 21.9, 21.9, 21.9. And the edge joints will have this value. How much? 10.95, 10.95. Your truss is ready for structure analysis. At this moment, your truss is ready for structure analysis. So first step, we need to do layout to figure out what is the spacing between main system, what is the shape of your truss to figure out what is the value of A and A prime. Once you select your layout, I'm gonna assume my values of load for structure and covering. And you have to decide, are you using flexible roof, just a corrugated sheet, or concrete? Once you select your values from these ranges, you can do your calculations. It's very simple, very simple. For structure load, your structure weight time horizontal area, A time S. Your covering load equal covering weight time inclined distance, A prime time S. Once you get BS and B concrete, you can add them together because both of them are dead load. Your final value will be concentrated load at each joint of the truss. The edge joints will have these values. Any question? Any question for this point? It's very simple, very simple. As I told you, for design courses, we don't have one solution because each student can assume different values, different spacing, different shape of trusses. So we don't have one value, we have different values, different answers. That makes sense? Okay. For live load, we have two cases. If you're sloping for sloping or flat roof, but slopes less than 10 degree. This slope or this angle 10 degree or less, probably flat. If your roof is accessible, you have a ladder to access this roof or stairs or something like this. So we have life load value equal 30 pound per square feet. If you don't have access to the roof, okay, we can assume the minimum value 15 pound per square feet. So please, first step, once you select the shape of your truss, you need to measure this angle. If this angle 10 degree or less, then the next step you have to decide, are you giving access to the roof? Someone will go there, or nobody will go there except for maintenance. So what is the option in this case? Based on this case, if you have access, okay, we can assume life load equal 30. If you don't have access to the roof, we will assume 15. Okay, you said if the sloping is 10 degree or less. What will happen if you have a sloping with angle greater than 10? What should I do? The life load will be 15 minus 0.5 time every degree greater than 10 degree. I'm sorry, I cannot understand this point. I cannot understand this point. Okay. We have a truss. The layout of this truss give you this angle like 15 degree. What is the value of life load? What is the value of the life load I'm gonna use? Okay. First case, if the sloping angle is 10 degree or less, I'm not in this case. I'm in this case, sloping angle greater than 10. So your life load will be 15 minus 0.5 time every degree greater than 10. So we have 15 pound per square feet minus 0.5 time every degree greater than 10. How many degrees greater than 10? The value is 15. So how many degrees greater than 10? We have 5 degrees. So I will multiply 0.5 times 5. This 5 is how many degrees greater than 10 degree. Okay, so 15 minus 2.5 equal 12.5. So your life load will be 12.5 pound per square feet. Make sure your final answer is not less than 8.5. Probably your final answer here something very small. So if you have something smaller than 8.5, go ahead and use 8.5. One more time. One more time. We have truss. This angle equal 8 degree. We have another truss. This angle equal 30 degree. What is the value of life load here? What is the value of life load here? What do you think? Okay, 8 degree, I believe we are in this case because your sloping is smaller than 10 degree. You need to get another answer. Do you have access to this roof or no access? If you have access, your life load will be 30. No access, your life load will be 15. That's it. For the second case, your sloping angle is 30. 30 means I am here. So your life load will be 15 minus 0.5 times each degree greater than 10. How many degrees do you have greater than 10? The total angle right now is 30. So we have 20 degree greater than 10. Your final answer will be 15 minus 10 equal 5. I will not accept 5. I will use 8.5 because the minimum value that can be used is 8.5. Please don't go below this value. If your value greater than this, okay, use the greatest one. Like I did here. Your value here was 12.5. This value is greater than 8.5, so I'm gonna use 12.5. If your value from this calculation is 5, which is smaller than 8.5, no, I will not use it. I will use 8.5. So guys, this point is clear? Do you think this point is clear? Okay. So I'm giving you some basics, rules, because you will design your project. You will do your layout. You are going to use your values and your assumptions. Okay? And everybody should be different. Okay, this life load is surface load. We need to convert it to concentrated load. By the way, any life load is horizontal projection. If you would like to convert the surface load to concentrated load, okay, go ahead and multiply it by horizontal area. A times S is the area assigned to each joint. Multiply it by W life load, you can get P life load as a concentrated load. And make sure the joint at the edge will have values because they are serving from one side only. We don't have anything from the other side. Let's do this example to calculate what is the final value of dead load and the life load as concentrated load at each joint. So the span of this truss is 130. So I'm gonna put my main system like this. Like this. I have a question. What is your choice for spacing S? We have a range between 15 and 30 feet. I would like to choose a value to give me equal spacing. We have 300 feet long, so probably I will use 30. That's fine, or 15, or 20, or 25. All of them will work. Okay, 30. What is the distance A? Is given 6.5. What is the distance A prime? And what is the angle here? We need to answer this question before going through the calculations. Okay, let's do what is the angle here first. What do you think? Okay, the height from here to the top is 6 feet. So this height is 6. This total distance is 650 50 feet. So I can do tan this angle, tan inverse tan 6 divide 65. This angle will be 5.3 degree. Okay, I can figure out the distance A prime. It will be 6.53 feet. They are very close because this angle is very small. Okay, let's do it. For dead load, let's start with the dead load. I'm gonna assume W structure 100. We have only corrugated sheet, yes, corrugated steel sheet only. So W covering will be something like 25 pound per square feet. So B structure will be 100 times horizontal area 6.5 times spacing 30. B covering will be 25 times inclined area 6.53 times 30. That means your dead load as a total will be PS plus PC. I am done with the dead load. Let's do this calculations. 19.5 kip. 4.9 kip. 24.4 kip. This is a total dead load. For live load, what is your angle? The angle is sloping angle 5.3, which is smaller than 10. Please read your problem carefully. Axis is provided. If the axis is provided and your sloping angle smaller than 5, you are in this category. Axis is provided, your angle smaller than 10, your live load will be 30. So the value of live load equal 30 pound per square feet. If you would like to convert this live load to one concentrated load, you need to multiply this live load by the horizontal area, which is A times spacing 30. Your live load value will be 5.85 kip. So your final answer, your value here will be 24.4 kip as a dead load, 5.58 kip as a live load, and your value at this edge will be 12.2, half this value, and the other value for live load will be 2.93 kip. So finally, I give you a truss problem, like you learned it in structural analysis. So guys, the scenario for any project of a steel structure, you will have area of land like this one. So you need first to lay out the project and choose your main system. What is the layout of the truss? What is the spacing between this layout? Then you need to go through this calculation to figure out what is the value of dead load, what is the value of live load. Finally, you will get a truss problem with concentrated load at each joint is waiting for analysis. We need to determine what is the internal force in each member. Once you will get the internal force in each member, you can design your truss.